Welcome, my dear learners. In this session, we shall be looking at the derivative of trigonometric functions. I guess you remember that in our last session, we were able to learn how to derive the derivative of the 6 basic trigonometric functions. So in this session, we are just going to apply this derivative in solving questions under derivatives. So let's take our first example. So we have our first example. Given that f at x is equal to sine x minus cos x, we have to find the derivative of these functions. But you know one thing about trig functions, derivative of trig functions, we don't do a whole lot of algebra. We just apply the formulas for the trig functions and then we substitute them back and then we are good to go. So with this one, we just start by writing that our derivative f prime at x is giving us now sine. We have already learned that when we differentiate sine, what do we get? When we differentiate cos, what do we get? So what we are going to do here is that we just differentiate each of these trig functions term-wise. So this is how we are going to do it. So we have derivative of sine x minus the derivative of what? Cos s. Very good. Now, when we differentiate sine, what do we get? We know that when we differentiate sine, we are getting what? Cos of the angle x. Then we have our minus sign here. Now, when we differentiate cos, what do we get? Now, we learned that when we differentiate cos, we are getting negative sine of the angle x. So from here, we just do some small algebra. So we have cos x, negative, negative, we are having what? Positive. And then we have sine of the angle x. So this is the derivative of this very function. You see how simple it is. So we have our next example. Given that the function h at x is equal to 3 sec x minus 10 cot x, we have to find the derivative of this very function. So very simple, the same method, the same approach. We differentiate them term-wise. So we know that our derivative h prime at x is giving us, we differentiate them term-wise. Now remember, 3 is a constant, okay, so we can just factor the constant out. So we have 3, then we differentiate sec x. Then we have 10 cot x. We can factor the 10 out. Then we differentiate what? The cot x. Now the next thing we are going to do here is to just apply the derivative of each of these trig functions, okay? So we are going to get, now when we differentiate sec x, we have already learned that whenever we differentiate sec x, it gives us what? Sec x tan x. But we already have 3 here, so we are going to get 3 sec x and then what? Tan x. Then we have our minus here. We also have 10 here. And then when we differentiate cot x, we know that the derivative of cot x is negative cosec square x. So the next thing we are going to do is just to apply our simple basic algebra. So we are going to get 3 sec x tan x minus minus, we are getting plus. Good. Then we have 10 cosec squared x, and this is the derivative of this very function. Very, very simple. So we have our next example. We have the function h of w, which is giving us this. We have to find the derivative of this very function. So we just have to differentiate this function term-wise, okay? So we know that our derivative h prime at x is equal to, so we differentiate them term-wise. 3 is a constant. We can factorize it out. Then we differentiate the function w exponent negative 4. Then we have negative, then we differentiate that of what? The tan. Sorry, the tan W. Good. Now you can see that this is a power rule, so you have to apply the power rule formula. So we are going to get 3 is already here. Applying the power rule, we have negative 4 W, negative 4 minus what? 1. Then we have minus, where we differentiate tan W. Tan W, we have already learned about the derivative of tan, tangent of an angle. So this is going to give us what? Sec square. Sec square W. So we are going to get 3 negative 4 W raised to the power negative 5 minus sec square W. Now we just have to multiply 3 and then negative 4 together to make it look nice. So we have 3 times negative 4, we have negative 12 W raised to the power negative 5 minus sec squared W, and this becomes the derivative of this very function. So we have example 4. You can pause the video and then try your hands on it, as I also do mine, and then we come to a conclusion to see if your answer is right, and then we move on. So we know that we have 5 sine x cos x. Looking at this, we have two functions multiplying. We have the function of x and then the function of what? Cos. So what we are going to do is that we have two functions multiplying. We can apply what? The product rule. So we know that this, we are going to get our f prime at x, which is the derivative. We can bring our 5 out because it is a constant, and then we differentiate sine x and then cos x, and then we differentiate that of cosec x. Now you can see that this is what, as I said earlier, this is a two functions multiplying, so we can apply the product. So we know that this is product of two functions, so we can apply the product rule. Okay, so in applying the product rule, we keep the first function, we differentiate the second function, and then we keep the second function, we differentiate the first function. So we know that our derivative, we are going to get 5 out. Now we keep the first function, which is what? Sine of the angle x, and then we differentiate the second function, that is the product rule. Then plus we keep cos x, then we differentiate what? The first function, which is what? Sine x. Then we have plus derivative of cosec x. So we are going to get 5. Now when we differentiate cos x, what are we getting? But we have sine here, so let's write the sine first. Sine, and then you differentiate cos x, we are getting negative sine of the angle x, and then we have plus cos x. Now when we differentiate sine, what do we get? We get cos of the angle x. When we differentiate cosec, I believe you remember, okay, when we differentiate cosec, you are getting negative cosec x and then cot x. Good. So let's do some little algebra here and then see what we are going to get. Sine x times x, we are getting what? Sine square x, but we have negative here, so we have negative sine squared x. Then we have cos x, we are getting cos squared x, or cos x all squared is the same thing, okay? And then we have minus, okay, there is a bracket here, cosec cot x. So let's expand the bracket. We are getting negative 5 sine squared x plus 5 cos squared x minus cosec x cot x, and this becomes the derivative of what? Of this very particular question. We take our last example. So looking at the last example, we have to find the derivative of this very function, which is f prime at x. We have to find the derivative. Okay. Now to find the derivative, as we've been doing, we take the derivative of each of these function term-wise. So we are going to get our f prime, which is the derivative, to be, we differentiate this function, then we differentiate that of what? This function. Good. So we have a ln function, a natural logarithmic function of sine x. So what we are going to do is that when you have a ln function, what do? We differentiate the inside function all over the inside function. So our inside function is what? Is this. So we have the inside function, which is this. So we differentiate the inside function, which is sine x, all over the inside function, which is the same sine x. That is what, when you're differentiating a natural logarithmic function of what? Ln. This is how we do it. You differentiate the inside function all over the inside function. Then we have plus. Now when we differentiate cos x, we know that we are getting what? Negative sine of the angle x. So we are done with this very part. Now let's come here. Now when we differentiate sine, what are we getting? We differentiate sine, we get cos of the angle x all over what? Sine x. This is that. And then we have, minus 4 sine what? X. Now we know that cos x over sine x is the same as what? Cot of the angle x, and then we have 4 sine of the angle x, and this becomes the derivative of this very function. Thanks for watching. Make sure you subscribe to this very channel for more updates, like and share. Bye bye. See you in the next video.